everybody. Got a quick little project here. Just thought I'd shoot some video of it. So this is a bearing housing. It's part of the apple processing line at the fruit cannery down in Fenville. Anyways, it has a bushing in here normally, and I don't know if you can see it, but they've run this till it cut completely through the bushing, wore a heck of a crescent in the side of it. So what they want me to do is bore this thing out to accept the next larger size bushing. It won't even clean up all the way, but they seem to not be concerned with that. So anyways, it's an iron casting. I wanted to stick it in the lathe, but I haven't got a forge josh set up yet for my lathe. Otherwise, this would be a slam dunk for a forge, obviously. Grab it, go in there with a boring bar. So instead, I'm going to set up here in the mill and do this with a boring head. I don't like doing this because material removal rate is always better in a lathe. Like, let's just dispel that myth right now. If you think you can get a bunch of material hogged out with this, you're going to be disappointed. It takes time. The problem you've got is, your stick out is just automatically enormous by the time you add the boring head, the boring bar. And if I had a boring head in here that accepted a big boring bar, would be one thing, but I'm running a little half-incher, so you got to be dealing with chatter. I do have some awesome boring heads. I've got a couple of Narexes, I've got a tree. The problem is every one of those is set up with Morse taper shanks for using in the boring mill. I don't have any of them set up usable in the R8. So I got this Flynn boring head that's on a 3/4 inch shank that I just grabbed on one of my R8 collets. So anyway, I'll stop yapping and we'll start getting this set up. This outside this, by the way, is just rough cast, pretty irregular. This thing basically self-centers in the application. So at this point, all we're going to do is we're going to set it flat on this face, which is a cast surface, so it's not that flat, but flat enough for what this thing's got to do. And then I'm just going to touch the sides, find the center of it, and that's where we're going to bore it at. So this is going to be an interesting opportunity to demonstrate the power quill feed on a Bridgeport. Now, a few notes about that. This is about the only thing you ought to be using the power quill feed on your Bridgeport for. I catch people all the time with big old 1-inch drill bit in there trying to hog their way through a hole. That is absolutely not what they're designed for, not rated for. If you look in the Bridgeport manual, it tells you to not exceed a 3/8 drill bit. Really, that function was never designed for drilling in the first place. So, that said, it's great for boring. If you take and slap a big old drill bit in there and go to hogging, the thing that you're most likely to do is there's a brass gear up here on the in-feed side, and you'll strip that out, or there's another brass gear down here on the side. One of those two is very likely to get up the ghost. There is a slip clutch built into these, but they've frequently been adjusted up over the years because people, I don't know how mine's adjusted. We'll see here in a minute. I'll try it. Yeah, see that? That's me overpowering the clutch. So this one is set correctly. My dad never tampered with it. It's pretty light. Basically, if you push it any harder than what it would take to drive a 3/8 bit, it just slips. So people get in there, crank them up, and then yeah, she'll push a 1-incher until it strips out one of those, or there's a set of bevel gears that'll break. I've seen every version of wreck that you can imagine one of these. And especially if you start wrecking the little bevel gears in here, I'm telling you what, it's a serious nasty project to take some of that stuff apart. You can end up with a head off the machine completely dismantled trying to get some of that stuff out of there. So resist the urge. Do not use your Bridgeport quill feed for driving big drill bits. So anyway, we're just going to get this thing set up and do a little... So this... I'm not going quite as crazy on the trying to keep it hammered flat because it's a rough casting. I actually am kind of letting it find its own center because I don't want to risk getting it cockeyed in there and then having it move later. I really want it to get a good grip on it. One other thing I'm going to mention, as long as I'm on my soapbox, I go into tons of shops and find this handle engaged all the time. Now, there's no reason for that. This is the primary disengagement for your quill feed. With that disengaged, none of the gear train is spinning. If you leave this thing engaged all the time, you're spinning that brass gear, you're spinning a pair of bevel gears here, you're spinning the entire 3-speed transmission over on the side, you're wearing stuff out for absolutely no good reason. And this particular set of bevel gears up here really doesn't get that much lube. That's what this little cup dribbles a little down into there, but it's not that awesome. So do yourself a favor, kick anybody in your shop in the shins that you see running it with this thing, and you'll see me, if I'm in one of your shops working on something and I walk past the machine and see that thing engaged, you'll see me look around to make sure nobody's going to scream at me and disengage it. So anyway, let's see what we can figure out now. This thing, by the way, was one of the things I had to modify this morning. It was on a shank with a 1 inch straight shank. Now, admittedly, much more rigid, much more usable, but I've been wanting to modify this to fit in the Bridgeport anyways, because that's really all I'm going to use this size boring head in. I've got a whole set of the really low travel, rigid DeVlieg boring heads that I use in the boring mill, so I'm never going to use this in it. So the Bridgeport, the biggest collet you can get in there is a 7/8, but I try not to use those. They're actually pretty weak, so I cut it down to a 3/4 inch shank this morning before I started videoing, so that it would fit here in the Bridgeport, because I bought this thing on eBay like 5 years ago and have never used it. So I thought, alright, today's the day. Alright, now, get centered up on this casting. Give that thing a flick so it's wobbling good, that way you can tell when you're getting closer. Yes, and find the edge without doing that, but the problem is you don't know when you're getting close. So by making it wobble like mad, it speeds the process up. So you see, like right there, I saw it start to touch. There we are. 5-0. Look it again, get a good wobble in it. And now we're going to hit the half button. Y1/2. Take that to center line now. That is really a handy feature. A lot of the older Heroes didn't have that half function in them. That is really nice because it saves you from having to add the offset of your edge finder or tool into it. So just go in there, touch, and hit the button and you're done. What's crazy, I don't know if I've mentioned it before, that digital readout that I'm running, one of the Chinese ones, I bought it specifically because I wanted to try one out. I've had a few customers that just didn't want to spend the money on a good one. So I wanted to see what I thought of them myself. And I gotta tell you guys, I'm as big of a Made in America fan as any, but that thing, I think it was $160 for a 2-axis digital readout. It's got every bell and whistle that the better ones that I would normally install, like a Fagger or if I want real high end, a U-All. And it has been dead nuts on, rock solid. I cannot find anything to complain about with it. There we go. So, 1/2 on X. Howdy, Wiggles. Hi. I don't know if the guys in the video can see you. If you hop up on the chair, you can probably wave to them. Making a video to show boring out this iron casting. Alright. Slide you over a little bit more. If you're going to stay up here and watch, you got to go get your glasses though, because we're going to start cutting metal pretty soon, and we don't want to wreck your little eyeballs.
Got it.
Those you? Where'd those ones? Where they at?
On the toolbox.
Oh, those are actually a pair of mine, but I guess you can use them. Just don't get them scratched up. So Wiggles has his own glasses, and it's mostly because he does things to glasses that really irritate me and make them all scratched up. So I normally make him get his own. We're going to let him use mine today.
And I can't find my name.
Well, so that's the other problem. Wiggles loses it. But, oh well.
You need glasses.
I've got glasses, I just don't have them on yet.
But where are they?
Right here. Glasses. Yeah, let's trade glasses. I like these ones better. That's why I couldn't find them, is because you swiped them. And I think we're going to go, well, I'm kind of torn here. I'm going to try about 600 RPM. I'll try a little hand feed here. I want to see what tightening fairly aggressively, but I think we can make that work. So, like I mentioned, we engage power feed right here. I am on the fastest setting right now, which I don't like that. If I remember correctly, and feel free to comment if I'm wrong, I believe these numbers on the Bridgeport are thousandths per revolution. So you've got 1.5, 3, and 6. And I'm going to put her down here to the 3 thousandths per revolution. Now, gotta get the feed engaged. There we go. I think I'm going to change plans. I'm going to start off at the 1.5 thou per revolution. Sounding better than I thought it would. Of course, being cast iron, this cut's really easy. It's just a piece of steel. I wouldn't be able to take near that heavy of a cut and survive the event. We got a whole new problem here. So, this particular boring bar has got a step on it, and I had to extend it out further. Like, the spot where the step is at isn't quite far enough to reach all the way through this thing. Like right now I've reached the step on about, quarter inch shy of the bottom. So I'm going to commit the original sin here, and I'm going to take and go over on the grinder. And I'll take this up close. You see the step I'm talking about? If I take and grind just on this back side, a little bit of a flat end there, it's not going to injure this boring bar for the other uses that I put it to. So I'll be right back. We'll pause the video and come back when I've got that done. Alright, hopefully you can see what I was describing there. So I've just ground a small flat on this thing here that'll let me come on down past that wall. Because this particular boring bar holds, or boring head holds the bar exactly straight. I've had them with different angles in them. And if it had that, I'd be okay. I'm going to quick double check by holding it up against the outside. Yep, I've ground plenty far enough. So now we should be cleared for liftoff. We did. We came out the bottom. We didn't hit up here at the top. Our clearancing project on this boring bar appears to have done the trick, so I'd say everything looks good there. Just a little fun fact for you, if you didn't already know this, I get a lot of calls for Bridgeports with the quill stuck in them, where all of a sudden it's super tight, they can't move it. And most of the time when we get those calls, you find out the machine was cutting iron. I don't know what it is about that iron dust, but it finds its way, gets trapped in the oil, sucked up into the quill. I'm not even joking. 9 times out of 10, if we get a call, we always ask them, you've been cutting iron? And the answer is always yes. So if you're cutting iron with your Bridgeport, really watch your P's and Q's, because if that crap gets on your quill, you'll be calling me or somebody else or ripping your Bridgeport apart to fix the problem. Question with this project is going to be, how much of a cut can we take at a time? My experience with these is that usually not nearly as much as you want to. We're going to try seeing if she'll let us take 25 on a side. Now I'm going to confess right up front, I'm not super optimistic, but nothing ventured, nothing gained, right? So, the old saying goes, here goes nothing. We're going to feed this down by hand once, just see what it feels. Actually, I don't feel bad at all. Interesting. I'm getting the impression that this boring head is actually marked on the diameter. I don't think I'm taking 25 on the side. I think I'm taking 25 off the diameter. So we're going to bump her up to 50, and I think what we're going to discover is that that's 50 thousandths on the diameter. Alright, so off camera I was messing with it. I'm not loving it. I'm getting more chatter than what I want. And I was having trouble with this tool, even with my grind here. I think what's going on is I'm getting enough deflection here that I'm not cutting out, you know, without taking really light cuts. Basically, it's still wanting to rub on my tool up when I get near the top. So I had this thing. This is an old homemade boring bar. It happens to be 5/8 already, which is the size that this boring head takes. And I don't understand why, but it's got some oddball sized hole in it. So I'm going to bore it out to take, this is just an old junk carbide, actually thread mill is what it is. And it's 3/8. So I'm going to bore this out in drill press to take 3/8. Pop this in. Now one weird thing about this is it's set up right now to primarily be counterclockwise cutting. I don't know why somebody made it that way. We're going to go ahead and cheat and run it the other direction. It's just normally you would want to be clamping, how do I want to put it? You want to be cutting in a direction that's loading the side without your clamp because you got further to support. But we're not cutting heavy, so we're going to go ahead. And what I'm going to do with this is take this on my cutter grinder and I'm going to grind it to turn it into a boring tool. So that's what we're up to. I'll come back when I get that stuff accomplished. All right, we've been doing some MacGyvering. Wasn't real happy with how that other boring bar was working. So what I've done here, I had this homemade one. Now, like I was trying to show before, it was just hard to explain, is if I built this boring bar, I don't understand. This one looks like it's designed for counterclockwise cutting. So to use it clockwise, I would never put the set screws in the back side, the trailing edge of the tool. I'd always put them in the leading edge so that it's the shear force, basically, of having the tool right up against the edge of the hole there. It's better supported because this tool now is not supported until clear back here at this set screw, and it's just not as good for vibration, tool life. But in this instance, it'll be fine. I got a 3/8 diameter solid carbide thread mill that was broke that I've ground down to put an edge on. Now I'm fighting getting the chatter out of it, so I've been playing with this edge. I've run a couple of very chattery cuts in there off camera. We're going to see what it does. I haven't tried it yet since I just touched it up, but I'm slowly getting there. We're going to get this set up here and see what we can do. All right, let's see what she does. Got to kick in my VFD here a minute. As soon as we got this thing zeroed out, it's easier to just roll off center and come back than it is to keep cranking the knee up and down. So I want to see where I'm at. That's the first full pass I've made through there where the entire bore is out to about the same size. So 6.5. And yeah, I'm at 1.7. So I got about 30 thou to go, give or take a bit here. Alright. I want to find out here. I hadn't yet, if this thing is on the diameter of the radius. So I just took it out 10 thou, which I'm going to guess is 10 thou on the diameter, but I'd like to find that out now before I get down to my finished cut. Cruise out of here and see what that cut was once. Definitely looks to me like 10 thou on the down. Yep, that's exactly what it was. That's 10 thou on the diameter bigger. Now, I am really frustrated with the chattering fighting on this. We're going to pull this sucker a minute, and I'm going to quick try. Mark exactly how I've got it oriented in there. And then we're going to try reducing the relief angle on this load. My experience has been that's usually where the trouble is. You get too much relief and they want to chatter. So we're going to try reducing the relief angle. Now, I think we're just going to have to live with this. I'm having a hard time finding the combination that improves on this. Awful iron filings out of her way. You know, it looks ugly, but it really feels pretty nice. It's just leaving a singing pattern in the surface. I mean, we're just going to have to live with it. All right, everybody, that last pass in there proved to be the last pass. I'm not quite sure why. When you're fighting chatter, sometimes weird stuff happens. It cut a couple thou bigger than what I thought it was going to. And right now is theoretically 1,000 smaller. I was shooting for 1.687. I'm at 1.686. And to be honest with you, we're going to leave it there. This, you can see now where it didn't clean up. Like, we got a pretty good section in here. So when they squish that bronze bushing in there, there's quite a bit of area for it to deform into, and I think we're just going to leave it with the heavier press. An extra thou isn't going to hurt this thing. It's hard to see in the camera, but you can see I've got chatter marks. They're worse looking than what they actually are. Like, it's not a bad feeling finish. So we're done with this part, and we're going to give it back to them. In a perfect world, I'd like to see no chatter, and if I'd had this thing in the lathe, I could have accomplished that. But the problem you're fighting on a mill like this is, you know, you're sticking out here. I don't even know what I'm hanging out. I mean, that's 6-inch scale, so I'm hanging out a good... What you really want to think about is how far you are from the bottom bearing. And the bottom spindle bearings, like here, I've got like 10 inches between my tool and my last actual support. And that combination is just really bad for good chatter-free cutting. And that's where the lathe has got this thing kicked all to pieces. You got it grabbed in a 4-jaw here, nice and rigid. You got a nice, I'd have been in there with at least a 1-inch boring bar that was well supported. I'd have carved that whole thing out and been done with it in 10 minutes instead of screwing around with it for an hour like I did here. But hey, you make do with what you got. And at this point, we're still in that stage where we're getting the lathe set up. The new other lathe moved in, and we're just between shops and having to make do with what we got. So anyway, that's it, guys. Just boring job. Figured I'd show it just so you saw the power quill feed in motion. So catch you next time. Bye.